Hey guys, welcome to another Python tutorial. Now, this right here will be picking off of the last lesson we had. It's actually going to be lesson 1.2. I left off a couple of things, but we're going to hop right into that and cover also a couple of nuances that you may see with these data types. So let's hop right in. So what we got right here, we got a list. So what is a list? A list is a way to store as many types of data as you want. It can store any data type. It's a beautiful thing. It's very useful. As you can see here, we have one, two, we have a tuple, we have apple, we have bananas. I mean, we got everything. I mean, come on now. We even got a dictionary. I mean, what else could we add to this? We got even more. Let's try to add some notes. We can even add, I don't know, let's add a float, a long float, just for the heck of it. So if we go ahead and run this, we're gonna get, as you can see, 1, 2, the tuple, apple, banana, dictionary, and 50.0. Now you might wonder why it doesn't show all the zeros. That's because by default, it cuts off those trail links. But there's probably a way to get those to show if needed. But the idea is that you can store anything in a list. So very powerful. And we're gonna have a little nuance on it. Let's go ahead and do sort for the list, my list dot sort. Let's see what's gonna happen when we run that. Notice that we get an error. This is fair because when you use sort for a list, it's powerful, yes, because it lets you sort the list, but you gotta remember, you have to know what's inside your list, which typically you would at some times. But the idea is though, you need to make sure that all of those instances are of the same type. As you can see, we have tuple and int. So what it did was it said, 1, I can sort, 2, I can sort, but these right here, I can't sort. So I'm gonna cut off and stop here. It even check all these. It was pointless because we knew that 1, 2 are the same type, but this tuple right here does not match these data types. That's why it says tuple and int does not work. So just make sure, guys, that your list, when you make it, has all the same data types if you want to use the sort. Now move on to the next one right here. We got a set. Set is really powerful too. It's similar to like a list and a tuple that we covered in the last video. But one of the primarily things that's great about it, it has no duplicates. So as you can see here, we have 1, 2, 3, 2, 4, 4. Now you're probably asking yourself, those are duplicates. They are. Let's go ahead and run print and watch what happens. It's almost like it's magic. Oh, well, actually let's hide that so we can run it clean. As you can see, 1, 2, 3, 4. Now what happened? So even though it said you can store duplicates inside of it when you're defining it, when you print it out, a set, the way it works, it's mapped in a certain way where it sees one thing as one. So when it sees 1, it maps it. When it sees 2, it maps it. When it sees 3, it maps it. 2, it won't map it because it already know inside that set on a low level that I've already stored this. So it's no longer a need to account for that into this set. So very powerful if you're worried about duplicates. You also can add to it as well. You go ahead and do my set.add. And as you can see, you get 1, 2, 3, 4, 5 in a set. So one thing to remember that the set uses these brackets right here, and dictionary also uses that too. But the difference between those two is that dictionary, remember, has keys and values. A set just has just your values or your instances inside of it. Now, as far as the list, it keeps square brackets. And also to go back to a set, remember that you can also have any data type you want in a set, just cannot have duplicates. So let's go to a frozen set, even more powerful, but a little bit limited with it. So it's just like a set, but the thing is though, you can't change anything in it. So it's really good if you think about it as far as like, in this other languages, they have things called constants where, you want a value that you don't want to change. You may have like a newbie coder or programmer that may come on the scene, they play around with a couple of things, and now you know it, no one's able to watch Netflix because they shut the whole thing down. Well, hey, guess what? Frozen sets and consts are very helpful for that, but Python doesn't have const built in. Kind of hate that, but there's ways around it. And a frozen set is pretty powerful and kind of can also help a little bit on those areas where, you get a constant. So let's say you have like 3 values that you may need that have a certain const to it. You may be able to put like a dictionary inside this array right here. Let's go ahead and do it right now, just for the heck of it. Let's go ahead and do something. Well, actually, I take that back. You can't do that because the frozen set, you won't be able to access those values if you store a dictionary in it. But it still can be useful in the sense that if you want the way of a set and how it works, but you don't want anything in your set to change, you can't. And as you come here and notice, if we go ahead and do my frozen, we type dot, and we get a list of the methods, you don't see anything that's really about adding. It's more so like copying different, checking the difference between one set compared to another. So it's very much a constant type of data type. So still very useful. Going to a none type, very simple. A none type is simply like null in some languages, where it's just saying, hey, there's nothing here. So it's a difference between undefined, like JavaScript has, where it's like it literally was never defined. But this is a way of showing empty, like there's nothing here. So it's useful when you're emptying something out, you want to verify that nothing's there, or you run an if else statement, you want to check if anything's there, and if not, then run this. So it's different things you can do with this, but that's the main way. As we do null types, I guess you could say in Python, it uses none. Let's go on to bytes. You probably can get away with not really using this for a lot of people, but this is definitely, if you're in IoT, Raspberry Pi, it's pretty useful, because as most people know with bytes, you can't change them, and you wouldn't want to. When you're passing those things in devices, just IoT things, and you're sending data, information, trust me, you don't want the information to change because anything happen. But as far as like Python, it's still very useful to use bytes. It's different thing you can do. Maybe if you're making like a mail service and API, want the data in the mail to change, something you use a byte, typically you would with some libraries that have like already pre-built-in mail API type functions. But I did though is it's really mainly a low level that you probably use this on, but it's still very useful and important to know. And going over to the next, the Bytearray. It's pretty much just like the byte, but now, bytes you can't change, but with a byte array you can. So you go right here, we just define the byte array, the Python, and let's run this right here, my byte 0. That means we're going to be talking to the first index of this byte array, because it pretty much splits up the whole array of the byte. So if he did it right here, we would pretty much say hello, now it becomes a whole array. So every letter represents an index, just like here. Python is its own array now. So every letter represents index. If P is 0, Y will be 1. So as you can see, we did 0 equals 65 because that's the byte version of A. We go ahead and run it. And as you can see right here, we get Athon, which is not even a word, but hey, that's how a byte array works. And it's pretty functional if you want to make changes to things that are bytes. To go to our last thing, where you probably ask me why they include it. Trust me, I ask myself that as well, but hey, you need completion, right? And I love completion. So as you can see right here, one of the less, I guess, done with data type is a complex. In my opinion, in my whole 4 years of being a software engineer, I've never used this. I don't plan on. But like I said, for the people that do got to use it, here it is for you. And this right here simply denotes what a complex number is, 3 plus 4j. You would think it would do oh, we can't do plus, but if you do this right here, and we holler over here, it say literal 7. So it knows to add. But if we throw J on it, it just says complex. So it knows because that J, that it's a complex number. If you go ahead and print it out, we're just going to get exactly that, 3 plus 4J. So this is useful for more so on the complex side when you do like electrical engineer, signal processing, those different types of things that most people probably won't touch as far as as me as a software engineer. But the day comes, it's going to suck. But hey guys, thank you for staying to the end of the video. We're going to go over lesson 2 next week, so stay in tune for that.